Andrew, you want to start off?
All right, looks like it's on you, George.
Okay, I guess I had. Good morning. I didn't hear Andrew, but okay. So good morning. I'm George McClellan with REC Group. I've been here since 2009 doing the technical sales aspect of this job, supporting basically the United States and all of the technical questions that come up and education needs that come up for the company. Happy to be here today, and what we're going to do is roll through a quick product overview of what's new, what's latest here with REC. We'll talk a little bit about the company itself, what our background is, and then we'll go into a few hot topics right now. One of them is the MC4 connectability issue, concern, thing that's popping up right now, and then talk about NEC 690.12, which is the rapid disconnect for emergency responders, firemen. Basically, it's the fireman thing. And as Hannah said, we're happy to answer questions as they, just send them out as they come up. We'll get things done. I don't believe we'll use the whole time period here, specifically for the presentation. So with that, without anything else, I guess we will get started. Who is REC? For those of you who have not worked with us, this will be just a little brief here. REC is a leading solar module manufacturer. We're present throughout the entire value chain, including making our own silicon, making our ingots, wafers, cells, all the way up to module assembly. We are a Norwegian company with Norwegian heritage. We've been doing this for quite a while. Solar is our only business. We're not the solar branch of a large electronics company. Quality and reliability are the cornerstones of our product and our manufacturing. We have more than 20 years of experience, and right now we're sitting at about 1,300 employees. Most of those are at our factory in Singapore. What we do, as you'll see in the next slide, we are a global company. We do have a global presence. My office, you can see on the left-hand side, is in San Luis Obispo, California. Our corporate headquarters are still just outside of Oslo, in Norway. If you see in the lower right-hand corner is Singapore. That's where our manufacturing facilities are. We do support both coasts. We've got assets in Sacramento and San Francisco, actually San Mateo, and as well as Andrew King, who is sitting outside of Boston, and we have also a salesman in the Southeast in Gulfport, Florida. So we're trying to keep all time zones covered. We also got sales assets across the rest of the world, but we're going to focus on the United States today. So the history of REC, as I mentioned, we are a Norwegian company. Started in 1996 in Norway with wafer and silicon production. Started manufacturing solar modules in Galava, Sweden in 2003. Things started to really take off. We came to the United States in 2008 and started our relationship with EE Solar just about that time. So they've been one of our longest partners or actually they are the longest partner in the United States. 2013, we split up our silicon and solar business, and in 2015, we were purchased by we were wholly owned. We were a subsidiary at the time, and we were purchased by Elchem in 2015. And if you can see there at the bottom, we have just celebrated our 20th year of being in the solar business. So I think golf clap for that. We are one of the largest, well, we are the largest supplier, European supplier of solar modules in the industry. You can look at the numbers here and see that we are a player in the business. We aren't as big as as Trina and Canadian, but we do have over this year we'll actually, so these are 2015 numbers. This year we will be putting out about 1.4 gigawatts of product, which gives us a pretty good market share globally. That is growing, and I think we're right-sized for the industry right now. In the United States, we are the second largest residential provider of solar modules with just under what Trina is producing. You can see that we do provide just about more than everyone with respect to the residential share in the United States. And this is based on Q1 numbers from GTM. These numbers will fluctuate up and down. This year is going to be, it's a wild ride as we all are experiencing right now. But we expect to keep that and actually hopefully grow some market share this year. So where does it all happen? REC modules are manufactured at our fully automated, vertically integrated site in Tuas, Singapore. This is an actual shot of the factory. It's not an artist rendition of that. You can actually see that we've got solar modules on our rooftop there. It's just really a drop in the bucket. There is we run very large ovens there to process the silicon, and it takes huge amounts of energy. So that's not really providing much with respect to our energy budget there, but it is something. Well, we do have solar modules there on our own roof, which is great. You can see on the right-hand side there that that gives us our factory specifics. We've got about 1.3 gigawatts of capacity. One of the real keys there is that we're at 99.4% utilization of all of our equipment. So we're still running at pretty close to 100% utilization. There are a lot of factories out there that are that have a large amount of capacity, but they're not running at 100% utilization. And that's really the only way a factory can run effectively, is to run at high utilization. If you've got 5 gigawatts of capacity, but you're only running at 4 gigawatts output, you're not going to be making any money there. You're basically breaking even. Another key there is that there's only 8 operators per line at this site. So that means there's a high degree of automation, and automation is good. We want to have that. We want to have the robots building our product, reducing the amount of manual labor, increases the reliability and the repeatability of the product. So we're pretty happy about that. I think we'll touch on that as we go a little bit deeper into the presentation. So what do we make at this site? So this is where we'll jump into the product a little bit. I think most of the people, so Twin Peak came out last year. We're starting to see more and more of that uptake in the residential market. The Twin Peak is a 275 to 285 watt product right now. I think that the 280 is probably the most popular. Those are what's in most of the warehouses right now, and I believe that we have plenty of those to sell. You can see the difference there is that this is not a 60-cell module, but it's actually using 120 half-cut cells in a series parallel circuit. We'll talk about that, what the series parallel circuit looks like in the next slide. This is a 1,000 volt product. You can see that we've got the bus bars. We've actually used 4 bus bars, and we will be moving to 5 bus bars early next year, which again gives us a little bit more power and better energy production. There is 3 junction boxes on the back side of the module. We'll talk about that in a few more slides. These do have multi-contact MC4 connectors. These are not MC4 connectable or anything like that. These are actually multi-contact MC4s. They come with 25 modules per pallet, standard warranty, standard linear warranty of 25 years. The modules are certified as PID free. I mentioned that we are going to be doing a few upgrades to the product with a 5-bus bar cell and a few other things later on in the year or early next year, and that includes actually reducing the frame thickness and increasing the strength of the product by putting 2 cross members on the back side of the module. What that will do is give us a lighter and stronger product. It will also increase packing density, so we'll be able to add more modules per pallet, and that will actually decrease our shipping costs and able to get more modules out to you in less space. Along with this stronger, lighter product, the warranty will be updated. We're not exactly sure what those numbers are going to look like but on the new warranty, but we believe that the LID and first-year values will be improved with respect to degradation. So what are the technology enablers of the REC Twin Peaks series? There's 4 main advantages. The first, and it's very easy to see, half-cut cells. Why do we do the half-cut cells? It's ultimately to reduce your resistive losses, your I²R losses. It reduces the current of each cell by 50% because you're cutting the cell in half. By doing this, we're thinking, the numbers show about 4 watts per panel. The 4-bus bar cell reduces your internal resistance within the cell. Your current has less distance to travel to be captured by a bus bar. It gives you a higher fill factor. It also makes things more reliable. If you do have a restrictive current path or a cracked cell or something like that, there is alternative current paths for those electrons to flow in. And the higher fill factor gives you a better module efficiency and a gain of about 2 watts per panel. The real key here is a new technology called PERC, which is passive emitter rear cell. I like to say that a lot of the project is really, whenever you're doing new technology, one of the hardest things to do is to come up with a cool acronym that everyone will remember. So PERC is the acronym for this, and PERC has been around for quite a while. It's easy to understand. What you're seeing there is that PERC is actually a treatment on the back side of the cell where they provide a dielectric layer on the back side of the cell where any light that passes through the cell, which does not recombine, gets reflected off the back side of the cell and gets reflected back up into the module or into the cell for another chance at recombining. It gives you a higher output in low light and high light conditions. So it increases your energy production. It's not so much, it gives you a good gain in watts peak, but it also increases your energy production. And the interesting piece about PERC is that PERC is it's been, like I said, it's been around for quite a while. However, it's been around a while in the laboratory and papers being discussed and manufactured, but in prototypes. It's easy to understand. You can actually do this in prototypes. It's really, really difficult to do in high volume manufacturing. REC was one of the first companies to use PERC in a high-volume manufacturing environment. There's been a lot of, if you look in the your announcements, there has been a lot of announcements surrounding PERC. Other module manufacturers are moving to PERC. They say they're moving to PERC. They bought PERC equipment, but no one's really saying, hey, here's our new PERC product. Like I said, it's easy to understand. It's devilishly difficult to master, especially in a high-volume manufacturing environment. The fourth piece here is the split junction box, the fourth enabler. The split junction box, what it does is it you need to have the junction box in the center of the module based on the architecture, based on the layout of the cells. By splitting the junction box, you're actually decreasing the amount of thermal mass that is carried by that by a single junction box. You're splitting that up into 3 pieces. It decreases the amount of heat that's put into the module itself, thereby increasing your watts peak output and your energy gain. It also allows us to do the cell layout that is necessary for the most efficient packaging. The bad part is, yes, it's moved the junction boxes and the cables to the middle of the modules, and it's required some adjustment by the installers. But I think that the installers are, there's some pretty smart assets out there doing these things, and they've come up with some pretty good solutions on how to wire these things up and have good solid wire management for residential rooftops. So how does the half cell cut, how does that really work? You can see here is a circuit that shows the circuit of the twin peak module. You can see that you've got your positive connection on the left side and your negative on the right side. You have 2 parallel. You have 2 series circuits that are paralleled with bypass diodes in the middle of the circuit. Each one of those bypass diodes is contained within the split junction box. What this does is actually give you a higher fill factor, and that fill factor gives you a higher energy yield, because that's really what we're looking for. I know the customer is buying kilowatts, but really what they're really using is kilowatt hours. So one of the advantages that may be lost in all of this is the advantage during shaded conditions. You can see here we've got 2 circuits here. The top is a standard panel, and on the right side is the Twin Peak series. If you shade this model, the standard panel, you can see by shading at the lower end of that, you'll actually engage all 3 bypass diodes, and that panel will not have any output, which will cause that that panel, your system or your array, to lose a single panel out of there. If you've got inter-row shading at any time of the day, this could be a serious problem, or not serious, but this could be a problem that shows noticeable reduction in output. If you do the same thing with the REC Twin Peak series module, you can see that if you shade in a portrait orientation, if you shade the lower side of the module, what will happen is that only half of that array, half of that internal matrix will be affected by that shade. So you'll still be getting half of the module's production, which gives you a pretty good benefit if you are, like I said, if you do have inter-row shading, or if you're working on trackers and they actually have backtracking or something along those lines. This is a feature that may get lost in the design, but it's, you can see the science behind it. Go a little bit more into PERC here. So what it really is, you can see it's a dielectric layer between, on the base of the back side of the cell is actually between the silicon and the aluminum backside field layer. It increases the reflection of the light coming that makes it through the module and decreases the heat buildup by actually using the infrared end of the spectrum. As it's mentioned there, it gives us a second chance to be converted into current. Lower temperature is going to give you a, with the negative temperature coefficient, the lower temperature of the cell is going to, cell and module is going to give you better production. The best part about this increased energy yield, and that's what helps out the customers. You've got an increased energy yield with respect to the manufacturer and the sales team here. We've actually got a total gain of watts peak. So it's we're getting about 4 watts peak per panel based on the PERC technology. So with the Twin Peaks series, we had some successes with that in 2015 and early into this year. We have introduced the 72-cell version of that, 72-cell series size series module. Instead of 120 half-cut cells, this uses 144 half-cut cells. And as you know, there's a similar increase in watts peak with this. These are running at about 335 to 345 watts peak coming out. It's a great product for, you can see this being used in commercial industrial rooftops, and that's our target for that, and in utility scale. There is 1,000 volts. It is currently 1,000 volts certified. We do have a 1,500 volt certification for this product. That is a IEC certification. UL does not have a 1,500 volt certification just yet. This product it's going to come out using the 4-bus bar cell. However, that should be moving to a 5-bus bar cell later on in the production. Currently, it does have the split junction box, just like the 60-cell equivalent, using multi-contact MC4 connectors. This is a little bit thicker frame, so we've got 21 modules per pallet, so the thicker frame similar to our current 72-cell product. Same warranty, and again, all of the REC products are certified as PID free. The real workhorse of our product line right now is the REC Peak Energy 72-cell product. We're reaching the peak power on that is about 320 watts. We do have 1,000 volts and 1,500 volts system certified product. Again, this is a IEC certification for 1,500 volts. These are, it does have the 25-year linear warranty. When the UL certification is established and accepted in the industry, we will certify this to UL 1500. The 1500 VDC, the 1500 volts product is allowing for BOS reductions for large-scale ground mounts. Not sure if that's going to be used on C&I rooftops just yet. I think there are some confined space constraints with respect to 1,500 volts. But it is seeing a good uptake in large-scale ground mounts. One of the things that we did introduce this year and is been seeing mixed reviews is the Black series of our 60-cell product. It is the Peak Energy series. We don't have this in Twin Peak yet. Coming in at about 260, 265 watts for the black backsheet and black frame product. It's using, is 1,000 volt certified, and it's using the standard 3-bus bar Peak Energy cells. It may move to a 4-bus bar cell here with as we update the lines. It is currently a multi-crystalline cell. However, we have started producing this in a mono cell and doing testing on that. That should be available soon. Again, this is a niche product. We're not expecting to sell hundreds of megawatts of this, but it is something that we have produced. It is something we have certified and is available for based on demand. So talk with your key account managers on that and see if you are looking for a black product. So where is all this made and what's so special about it? So with REC, we are focused, as I mentioned earlier, we are focused on the manufacturing side of things, giving you a high quality, reliable product. All of our products, all of these products are being manufactured at Singapore in our vertically integrated site there in Tuas, Singapore. It is ISO 9000 and 14000 certified. Good part is that it is a flexible site and it is scalable. So if we see demand in a certain area, we can shift lines to be able to meet that demand. So REC, as we brought up earlier, we are vertically integrated. And this is one of the keys to our the control of the product and the reliability of the product. We do manufacture our own silicon with Elchem Silicon. Our parent company, we manufacture our ingots, wafers, and cells all in Singapore and transfer those into modules, all within the same. It's about in about a 200-meter span, you can get all this manufacturing done, which is really nice. There's no contract manufacturing at this site. We're not bringing in wafers and ingots and such from other areas. We've only got one supply chain that we are working with on this. And the interesting piece here, if people are watching, is that right there. That's a barcode at the end of a block of silicon, and that will then be sawed into wafers and manufactured into cells and then modules. But we're actually controlling, serializing and serially controlling all of our products all the way down to the source silicon. That allows us to understand everything that's happened to this module, basically all the way back to the source silicon. It gives you a very good understanding of the quality of your product. If something has gone wrong, we know every step that module has gone through, or that cell has gone through, all the way back to the source silicon. This is in the factory here. What I'd like to point out, we've actually got a longer presentation on this. I think we'll only touch on 1 or 2 slides in the factory. Interesting piece here is, count the number of people that you can see. And you can't really see any. There's usually the people that you're seeing in the factory are usually maintenance, doing preventative maintenance and on some of the equipment. But this is our soldering unit that does the stringing and tabbing. It's done with inductively controlled soldering, which is non-contact. It's pretty impressive to jump into this factory and take a look at how fast these things are moving and the quality and the repeatability of this product. So if you're having your modules built, you can do them the automated way, or you can use something along this line. Now, the interesting piece is that yes, there is manual assembly can do some amazing things. These manual assembly is solid, it's fast, but I pretty much guarantee you that the people, each person here is doing things just a little bit different than the person next to them. The robots that are building these things are not they're not concerned about dentist appointments or what their kid's going to wear to prom or anything like that. They are focused on one thing, and that's making sure that good stringing and tabbing is done. Like I said, not to dig manual assembly too bad, but the way I pretty much would prefer to have my modules being built by automated assembly. What this does, so with the design and manufacturing, builds a highly durable product and reliable product. So the reliability we'll talk about a little bit later. The durability, we get the question, hey George, what about hail resistance? Are the modules, how do they perform in hail? And they perform in hail very well. All the modules are tested to the IEC and UL standards for hail testing, but what is the real world applications of this? And here's one of the ones that we've seen. This happened in 2012. We get maybe one or two of these photos a year of people saying, hey, look at this, we had insane hail and your modules did fine. This was one in Virginia that Direct Connect Solar sent over to me a while back. But yeah, they had 1-inch hail coming down, damaging cars, breaking out windows, all of that, and not a single PV module was damaged. And we hear this quite often. So the good part is that yes, the modules do quite well in hail damage. So how does that all play out? One of the ways this plays out is with the reliability. So you've heard a lot about reliability. What does that really mean? What that means is that we have a very, very low product return rate. The best in the industry is what we claim. Of the product that is out there right now, we are seeing a claim rate of about this week's claim rate was down at about 26 parts per million. So for every million modules that are out there, we're seeing an annual claim. We're seeing an annual failure rate of about 26 modules out of that million, which is a pretty solid number. That comes out to about 1 module for every 5 megawatts. Which keeps us very, we don't worry too much about the module failures. We do have a team that is focused specifically on claims, warranty claims, and we are using this information. If we do see a high claim rate or something that is repeating from time to time, we use that to improve the quality of our product. There's also a parallel feedback claim. There's a parallel feedback loop for non-claim issues. So if you're seeing something that's not really a claim, but you feel it needs to be brought to our attention, there is a path for that on our website as well. So you can look at this and say, George, that's great, but that just tells us the story with REC. What are the other manufacturers doing? So we have a pretty durable and reliable product, but other manufacturers out there do as well. It is difficult to get information on other manufacturers' claim rates, but as part of a publicly traded company, they do have to publish some of this information. So there's a publication called Warranty Week that reviews all of the Security and Exchange Commission's data and has puts together charts on this. So we looked at the charts and we pulled a few out as you can look to see, in the upper left-hand corner, our friends at First Solar, the red line is what you want to look at, is what is the rate, the claims rate. And they're running at about 1%. And then you can see that Hanwha, when we had information on them, they were, a little bit higher than 1.5% a claim rate. So the green line is actually the accrual rate. That's how much money they take out of their revenue to prepare for warranty claims that do happen. They're required to do that. You can see SunPower in the lower left-hand corner, a little bit rocky there with the claims rate drifting around anywhere from low to over 1%, and then down and up again. So a little bit rocky. So last year they were at about a little over 1.5% of a claims rate or in-field failure rate. If you look in the lower right-hand corner, you can see REC, our claims rate, is not at the 1% or 0.5% or even 1/4%. We're down at 29 thousandths of a percent for 2015. And you can see that that has been, and the good part is that the claim rate is low, which is excellent, but also the claim rate is steady, which means we have our processes under control. We're seeing the benefits of automated manufacturing. Interesting piece, if you look at the lower right-hand corner of the graph there in the REC, you can see from 2010 to 2011, the claims rate slowed down drastically. It went from almost 1% down to very low numbers. That was the introduction of automated assembly. From 2007 to 2010, we did a semi-manual assembly. You can see that the quality of the product reflected that. Once we started moving to a automated assembly in 2010, our claims rate dropped drastically and has stayed low. So again, you can look at these numbers and say, George, what does this really mean to me? My manufacturer, the people I'm buying from say, we're going to cover your claims regardless. Well, what I like to say is the best warranty out there is one that you don't have to use. I don't want someone up on my roof replacing modules unless, I don't want them up there. So we can look at it that way. But what does this mean to a project owner? If you've got a 1% failure rate, you've got 36 modules per megawatt failing. So if you've got 5 megawatts out there, you've got nearly 200 modules per year failing. That's 200 modules that you have to go find and replace and then file a claim on. Even at 0.5%, you've got 18 modules per megawatt failing. It may seem like a very small number, but if you're tracking down 18 modules per megawatt failing, you need to be spending your time selling and installing, not tracking down products that shouldn't be failing. You can see once you get down to the 0.003, you're actually getting to less than a full module, that you have to call that a full module. So that's what failure rates really mean. And like I said, we all need to be out selling and installing and not tracking down products that are failing and not dealing with customers that are upset with us because they've got 2 modules out on their rooftop. Next topic that we'll roll into is we get the questions a lot about connectability or compatibility with MC4 connectors. Some manufacturers are issuing a document that actually states that there is connectability with MC4, compatibility with MC4. And what that's really doing is stating that the MC4 will fit on their connector and perform. The bad part is that MC4 is saying the only thing that can be connected to an MC4 is a multi-contact MC4 connector. Anything that is connected to that other than an MC4. If anything else is connected to an MC4 connector, it will void the MC4 connector warranty. So if there is a, if you end up doing that, you end up taking the liability on yourself or on the project. So understand that. Read if you do. I know that a couple of manufacturers are out there providing documentation that says, yes, you can do this. They stop short of saying that they will warrant the product. They will warrant the connection. Understand that. And there is if you go to the MC4 or the multi-contact MC4 webpage, there actually is a statement around that. Maybe, may not be this dramatic where you need to have a beware and skull and crossbones and all of that, but just understand that this is where things need to go with respect to MC4 and actually MC3. I don't think anyone is using that anymore. So the next topic that we'll touch on is Article 690-1 or .12 from the National Electric Code 2014. It's a rapid shutdown of PV systems. This came out of emergency first responders for firefighters. How can the firefighters feel safe on a roof with solar modules on them? So they came up with basically we've all agreed on that, yeah, how we can keep you guys safe is that we can define a safe zone. That zone is basically 10 feet away from the array. Your conductors need to be limited, controlled to a maximum of 30 volts within 10 seconds of shutting down the system. Also, the modules or anything that goes inside the house, within 5 feet inside the house, so into inside the attic or something like that, if it's more than 5 feet inside, those conductors need to be similarly controlled to less than 30 volts. This is not, NEC 2014 does not require module level shutdown. Regardless of what some people are saying or what the AHJ may think. But let's not get into what AHJs are thinking or saying. Also, a placard's got to be placed where the first responders are going to be cutting off the electricity in the fire. I think a lot of us have done this, but again, module level shutdown is not here yet. This is what NEC 2014 says. This was from a SMA white paper that was published a little while back. You can see the area of controlled conductors and versus uncontrolled conductors. So there's a 10-foot exclusion zone currently. If you look, where the confusion, I don't say confusion, where things are getting spun up is NEC 2017 has been proposed where they bring this in a lot closer, where it's 1 foot from the array. However, by breaking that down to 1 foot, you are looking basically at module level disconnect. And that module level disconnect, you're not going to be able to get much lower than the module voltage themselves. So that's going to be at about a minimum of typically around 36 volts. So if you have two connected together via a microinverter or something, you want that less than 80 volts. As I mentioned, SMA put together a great white paper on this. The link is there at the bottom of the page. So that's coming at the introduction of NEC 2017. Not there yet, people. Let's not jump the gun and start demanding this until we have solutions in place, and there aren't a whole lot just yet. I think our microinverter people are very happy that this is being implemented, but not everybody needs to have microinverters on their with their arrays. So right now, this is the NEC map. You can see most of the United States is operating on NEC 2014. California blissfully is not. Got to do things our own way out here, I guess. However, there probably will be a fairly quick uptake of NEC 2017 as it comes online. I know the East Coast, particularly the Northeast, is very keen to get this rolling. And I believe that is all we have to discuss today with respect to the technical topics. All of this information should be available on our homepage. Product downloads, studies, and white papers. We actually have images and videos there that are available for your use. Contact info. We've got our link to our YouTube page and the information that's going on there. So that is all that I've got right now. Thank you very much for all of your attention and being here today. We look forward to working with you throughout the year, and look forward to seeing you all in Las Vegas if you're going to be there for SPI. So Hannah, I'll turn it back over to you.
Yeah, thanks, George. So that concludes the presentation portion, and we'll move into our Q&A session. So George, we have a couple of really good questions here for you. Okay. The first one we have, what does PID stand for?
That's potential induced degradation. So what that is you have a loss that will happen in high potential systems, specifically high potential systems in operating in high humidity environments. Sometimes you'll actually get a current leakage path that is developed due to a high potential. Most manufacturers, we aren't seeing a whole lot of that in the United States because we ground our systems. You see that in other areas outside of the United States that use non-grounded systems. But what it stands for is potential induced degradation.
All right, thank you. The next question we have, and just a reminder to everyone that when you do exit the webinar, that survey will pop up. And if you complete that survey, we'll send you a copy of this presentation. Okay, and the next question we have, how much of a loss does black suffer versus white? And I'm assuming that's back sheet.
That's a fantastic question. So there's two things that happen there. The white back sheet actually gives you a reflection, so the light shines off of reflects off of the back sheet and is reflected into the cells. It gives you actually about a 5 watt per module increase in watts peak. So this is only during flash test. So what happens is that you have to downrate your modules. You lose about 5 watts per module. So a 275 white backsheet module will actually give you 260. It'll flash test if you put a black backsheet on there. It'll flash test at about 265 watts. So what we're doing is we're actually giving up about 5 watts to gain that aesthetic. Now the other interesting piece is that you're not going to see much difference in energy production. So with a regular, so if a 265 watt white backsheet and compare that to a 265 watt black backsheet, they'll actually perform very similarly with respect to energy production. And the reason is that yes, the people are thinking that the black backsheet product will actually get hotter. Actually, what happens is that the black backsheet product will heat up a little bit faster, but it's not going to heat up. What will happen is it gets into full sun, the cell NOCT will take over and be the dominant effect in that system. So the system will actually work, will be running at NOCT, which is going to be higher than your ambient temperature. So the black backsheet product will actually heat up a little bit faster, but ultimately your energy production is going to be very similar to a white backsheet.
Great, thank you. The next question we have, do you have any plans for module integrated optimizers?
Absolutely. So we're looking at that right now. It's really demand based, and as we we call it the Twin Peak IQ products. It's difficult right now because there's still a handful of there's still a bunch of optimizers out there, and the industry has not chosen which one they really want. So it's difficult to run a couple of different part numbers. You really want to only certify with one product. But that, keep your eyes open. There may be something at one of the trade shows being introduced this year with the Twin Peak IQ product. It's not on the market yet, but it will be as demand requires it.
Great, thanks. The next question we have, does each junction box in the dual Twin Peaks only have one conductor, or is it a negative and positive from each box?
It only has one conductor, so there is on the left-hand side is the negative, and the right-hand side is the positive. So those are all, it's just one conductor per junction box in the split junction box.
All right, and the next question we have, my installers tell me that wire management is more difficult with the Twin Peak modules. Have you heard this or any ideas?
I hear it every day, and we apologize for that. Yeah, it's difficult because it's different than what we have been installing for the past 10 years. I agree completely on that. This is something that is required by the packaging of the system. We feel that the wires are long enough, the cables are long enough to do all types of all orientations of modules. We did a fair amount of work with installers ahead of this before we introduced this packaging to ensure that we would not that we'd be able to wire up the systems and not have any areas excluded or any orientations excluded. It will require some ingenuity and some rethinking of some ways. So yes, we as an industry won't be able to do things exactly the same way we've always been doing them, but I think it gives us an opportunity to figure out some new best-known methods and processes. So I can't really say, all the systems and all the arrays are going to be slightly different, so there's really no best-known methods yet. But I think it's the more that are getting installed, the more people are figuring this out and coming up with some unique solutions.
All right, well, that's going to wrap up our Q&A session. Thank you, everyone who submitted these great questions. I think Andrew wanted to say something to wrap up the webinar.
Can you guys hear me this time?
Yep, loud and clear.
Perfect. All right, I apologize to everybody. I was having some level of technical difficulties. May have been operator error, but nevertheless, I just wanted to say thanks to everybody for being on the call. Kind of to reiterate what George said, we really appreciate your support of both AEE and REC, and look forward to working with you guys in conjunction with AEE moving forward. If there's any direct questions that you have, obviously I would go with your account rep through AEE, but if you wanted to reach out to me, you can also feel free to do so, and I could always put you in touch with the right person over at AEE. My email address is andrew.king, K-I-N-G, @recgroup.com. So again, thanks everybody. I really appreciate your time, and we'll see you hopefully at SCI.
Great, thanks, Andrew, and thanks again, George, for an awesome presentation. Just want to remind everyone to complete that survey, and yes, as Andrew mentioned, feel free to contact your AE sales rep for any additional questions, more information, and to get a quote for your next order. And a reminder that this will also be uploaded to our YouTube channel later today. So if you didn't get a chance to catch the whole thing, or you want someone else on your team to see it, just go ahead and check back there probably within a couple hours, and I'll have it up there. All right. Well, thanks again, everyone, for joining us this morning, and have a great rest of your day and a great weekend.
Okay, thanks a lot, Hannah. Goodbye.